So hi guys, welcome. My name is Lee Boonstra. I work as a sales engineer for Sencha. Some of you might know me already. I'm here today to talk about ECMAScript 6, or the official name is ECMAScript 2015. Basically I'm going to explain the top 10 best features, or the features that I think that are really great and cool. Now obviously there are much more features in the new ECMAScript standard. I just had to pack it all and wrap it all in a 45-minute time frame. So this is why I came up with this, these sets of features and this presentation. But ECMAScript, that's actually the standard. So the JavaScript, what we know, what runs in our browsers or in Node.js runtimes, that actually all comes from the same base standard. And this standard is written by the ECMA International organization. This is an organization where all big companies or corporations like Microsoft, Google, Adobe, and Intel all come together and they create a set of standards, a set of rules, where they say like, these are the rules for the future of the JavaScript standard that we eventually want to implement in our browsers. Now, as some of you might know, I work as a trainer for Sencha, so I love to teach code. I like to talk a lot. I'm going to show you lots and lots of code examples, and now don't get all like in panic if it goes way too fast for you. I'll make sure that I post for every code snippet a GIST example, so that I host in my GIST account. So then afterwards, I'll just give you the URL so you can go into my slide deck and then you can just open all the code examples and execute it yourself and try it out, play around with it. Before we start, just some terms that I just want to make clear. So JavaScript, that is the language name. So the language that we all write. ECMAScript is the standard. What you often hear when people talk about ECMAScript or ECMAScript 6, they also talk about transpilers. And a transpiler, what that basically means is the new JavaScript standard is not supported by all browsers yet. And to do this, we need to compile our JavaScript code to the JavaScript code that is currently supported by browsers or by Node.js runtimes. So that's what a transpiler does. It just compiles it back. It transpiles it to ECMAScript 5 code at the moment. Now, what is TypeScript? Because that actually also goes hand in hand with ECMAScript. It's also a programming language. It's actually created by Microsoft. And that's a superset of JavaScript that helps you with type checking. So, for example, when you open your IDE and you write a method, and in this method there are like a couple of arguments that you pass in. And let's say one of the arguments is first name. That should be a string. If somebody passes in an integer, then all the alarm bells go off because that's a wrong type. And TypeScript, that usually has its own extension and a TypeScript file that does the type checking for you, but compiles it back to JavaScript code. Some history. ECMAScript standard started in the late 90s. ECMAScript 3 is probably the one, or that's the one where I started coding JavaScript with. That one existed for quite a long time. There was an ECMAScript 4, but it never really became official because the spec was created by the browser makers, and then eventually nobody ever could agree on things, and then they decided to abandon it. So then there was no new standard, and everybody was stuck with ECMAScript 3 again. So ECMAScript 5 that was created in 2009, and that is actually the standard that is currently working still in our browsers. ECMAScript 6, or ECMAScript that got finalized in 2015, that is the new standard. And that is finalized now, but now browser makers need to implement it in their browsers. So it works in most of the modern browsers. V8 engine, and that's the engine for Google Chrome and Node.js and Opera. Or JavaScript Core for WebKit and Safari. Chakra, that is Microsoft Edge. SpiderMonkey for Firefox, and also on the latest mobile operating systems, the ECMAScript 6 standard probably will work. But that also means it won't work in Internet Explorer. Not in Internet Explorer 8, not in 9, and not in 10. It might not even work in Internet Explorer 11. So this is why transpilers are important, because you cannot create an app that works in production if you need to support one of these Internet Explorers. So. So these are the features that I like to talk about with you. And I like to start talking about block scoped constructs. And to explain what these are, I first like to get back and start talking about JavaScript hoisting. And I'm just curious how many of you know what JavaScript hoisting is. Okay, some. JavaScript hoisting basically means that when you create variable declarations, they will be treated like if they are in the top of the function, or otherwise they will be moved. And now I remember that back in the days when I started JavaScript, or coding JavaScript, and it was a very long time ago, I think maybe 15 years ago. And it always, for me, it was strange when you would create, for example, in a scope, and you would call a function, and you could call the function already before it was even written in your code. See, in this case, I call foo, but foo is actually declared afterwards. Now that works fine, but it always amazed me that as soon as you put a function in or you save it to a variable, then the same code snippet would break. And why is that? Here it would say error, foo is not a function. It also says, like when you run a type of a foo, it says it's undefined. But the reason why that is because a browser, this is how a browser actually interprets it. This is how a browser sees it. So a browser would create or declare the variable on the top of the scope. It can be in a function, can be in a window scope. And that's an undeclared variable. So there's nothing assigned to the variable yet. That's also what you see. If you run a type of, it says like, yeah, the variable is undefined. And then it starts creating an anonymous function where it actually does this stuff. And then you call the function, and the function foo doesn't exist yet because you didn't assign the anonymous function to foo yet. So that is why this breaks, because JavaScript is hoisting variables to the top. That is something that is very unique in programming languages, or in most programming languages don't deal with that. And that is the reason why ECMAScript 6 came with block level declarations, block level scopes. So what that means is they created a couple of new declarations, actually the let and also the constant declaration. And yeah, you can put these declarations in the middle of your function, for example. And yeah, it exists only in that scope. So for example, when you put it in an if-else block, then it only exists within the curly braces of that if. Or in a try-catch block, it only exists in that scope. Or it can exist in a function scope or in a window scope, but only within that scope that declaration exists over there. So here you see the same example where I changed the var for a foo. And now this same example won't magically work anymore, no, because it only exists in that scope. But the reference error in this case totally makes sense, because now it tells you like, yeah, there is a reference error, I cannot access foo. And it won't even get further because it stops there. So that it kind of makes sense, like for when you're like nowadays when people write JavaScript code, we always tell people like, yeah, it's a good approach to write your variables all in the top of your function scope and don't assign or declare new variables in the middle of your function. That is actually because of hoisting. Here you can see an example. I create a variable bus and I set it to Sencha. Now if I create another declaration, in this case let bus, I get a syntax error here because I cannot declare it again. It was already declared, it's set to Sencha. But this example would work because in this case now let bus is in a different scope. It's in a block scope, in the if box. Outside of the if, it doesn't exist anymore. Outside the if, bus says Sencha. Next, besides lets, there's also constant declarations. And this should be used for constants. And constants, I think it's just like in Java. You shouldn't change a constant declaration. So you assign a value to it only once. And then afterwards, you cannot change it. So here in this case, I would personally use these things for saving settings or stuff. As long as I know, like, I'm not changing the variable anymore. So here in this case, you can see constant is live URL, and then I put some feed inside of it. But if I later change it to another feed, it breaks because, yeah, is an invalid assignment. Constant already exists. I can also not create a constant with no value because you cannot change the constant. So declaring a constant with no value, that's a waste. That doesn't make sense. So that this case gives a syntax error. But it only prevents you from modifying the binding. So if you assign an object to the constant, you can change whatever is in that object because the pointer to the object is still the same. So here, that's what you see in this snippet. Now, that we're talking about this, I do want to mention or point this out because a while ago I was reading a blog post and somebody says like, oh, this is great, ECMAScript 6. You know what I do? I just take my old existing code and I just do a Control F and Control Replace and I replace all my vars for let. And I cannot explain how stupid that is. That's really, I mean, that's crazy because like think about it, like a variable that exists to change your variables and the scope doesn't really, is irrelevant because it just moves it up to the top. And unless you are a good programmer that always puts your variables in the top of your function, then it's probably fine. But we developers make errors, right? And we do sometimes funny things. So if you do a control replace, it could be that suddenly your scopes are changed as soon as it's a let. So your code can be broken. Another thing is, for example, when you do stuff like debugging or you're like rewriting your code and you're moving blocks of code, pieces of code around, you're changing also the scope. So using a let as a declaration is definitely scary. You really need to know what you're doing here. And the same is with constants, right? So that is that I want to give you as a gotcha. Let and constants can create dead zones. You want to be careful of that. But yeah, they work in different scopes, and constants they can change the binding. Default parameters. That makes sense, for example, when you create a function like this. Here in this example, I create a function makeRequest, and this function has 3 arguments, URL, timeout, and callback. And now the first one, I assume that everybody always passes in a URL, but timeout and callback in this case are optional. But yeah, I need to check if this indeed was not passed in or was passed in. So usually people, what they do is they do some checking inside of the function body to figure out like what's going on. And although this is not wrong, this is totally fine. But in ECMAScript 2015, you can enter default parameters. So you can already put the default assignment already inside of the braces, parentheses. So in this case, I say timeout is to 2000. And I don't need to put anything in my body. It keeps my body nice and clean. So that's it's just like many of these ECMAScript 6 features, by the way, are just there for developer productivity or readability, so that it just helps you as a developer. But the stuff that it actually does is not new. These are stuff that you could do already with old-fashioned code. Template literals is also very nice. I always figured that like strings in JavaScript, they're always a bit laggy when we're talking about strings, especially when you work with strings that exist over multi-lines. Because I'm quite sure we all have dealt with stuff like this before, where we create a multi-line strings with double quotes, and then suddenly I need to use that double quote within my string, so I need to either escape it, I need to concatenate strings to each other. I do that with the plus character, and if I want to assign variables to my multi-line string, then I also need to concatenate variables to it. The new ECMAScript 6 way is much nicer. In this case, you can use the backtick character. That's what you see in the beginning of the line. And the backtick, that's not a single quote. That's a different key. So on the American keyboard, I think it's next to the 1 key. But it allows you to write strings over multiple lines without concatenating it with the plus I character. And when you want to assign variables to the string, you can nicely use these placeholders. This kind of stuff is for us Sencha developers is not so impressive because in Sencha we have XTemplate. We do this already for years. But yeah, for other, like for native JavaScript developers, yeah, this is a big thing, right? Same as with XTemplate, also in ECMAScript 6 you can use kind of functions with your templates. So in Sencha we call that member functions, but in ECMAScript 6 it's called a tagged function, and a tagged function is basically before you create your string with the backticks, you tag it with some function name. So in this case, I created a function named myTag, and yeah, it does something. Well, in this case, it just takes what was passed in, and I output it in uppercase characters. So yeah, multi-line strings for the win. That is much nicer to read than when you're doing all that stuff by yourself. And the next topic, these are arrow functions. I'm quite sure that you might have seen this already when you are Googling stuff on Stack Overflow, and developers all want to show the latest fancy things, so they write functions in with arrow functions. But I remember the first time when I saw that, I thought like, whoa, what is this? It's not that difficult actually. It's much easier as long as you know what it is and what it does. But let's say in ECMAScript 5 you had a function like this. It's like you have a function that has like 2 arguments that you pass in, and then you return something. So in the first example you see I pass in x and y, and I return the sum of x and y. And in the second example I concatenate a variable to a string. I could rewrite this in an arrow function. There are 2 ways in writing arrow functions. This is the way that has a bit more characters. I could say let calculate, and then instead of writing down function, I just start with the parentheses, the x and y, and then I create this arrow, and I say, and then the body of the function, which is return x plus y or return hello name. Or I can write it on one line. So that saves you from typing. It's a bit easy, yeah. So now in this case I just start with the parentheses x, y, arrow x plus y, because it knows like whatever is in the function body should be a return statement. Yeah. Now this is something that you need to be careful of, because you cannot rewrite every function to an arrow function. Arrow functions are totally different than normal JavaScript functions. For example, there is no this, there are no super, and there are no arguments. So you can also not use duplicate arguments when you pass things in. You cannot create instances with new from an arrow function. There is no prototype. You can change the this. There is actually a lexical this. And a lexical this, for example, what we all as JavaScript developers do is we often create like a new variable called var me is this, or var self is this, and then we assign the current scope in that one, and then we do something asynchronous, like maybe a set timeout function, or maybe a call to a database, and then something will be returned. It comes back with a different scope. So if we want to go back to the original scope, we always call me or self to figure out what the original scope was. But with a lexical this, that's not the case. A lexical this means like the this is always the parent scope. So that's totally different. Now with these arrow functions, I would say it's great to use it, especially when you're defining callbacks. For example, you make a call to a database and there is either a success statement or a failure statement. Now in that case, you could write it all out and you write up all these inner functions, or you can just write a simple arrow function on a one-liner. That could be nice. But I would tell you, as soon as you work with teams of people, just be careful with writing these things out, because you need to make sure that everybody understands what it means, because it's not really a goal, I think, to create puzzles in your team and that other developers get a headache. So just be careful with what you do. The structuring assignment. that is handy, for example, when you deal with big objects. So I think especially when you make calls to an external system or server, and you get like a big object, a JSON object back, everything is nested. And you want to, in this example, for example, I want to make use of all the images that are in the nested objects. Now in ECMAScript 5, you would probably use the dot notation, and you would probably save this to a variable, so you could start using it. And that is fine. But there is a new way in ECMAScript 6, and that is the way of destructuring. So in this case, I can create a declaration, let's say a let. And then I start with the curly braces. And so the first one is the root of the object. And every other set of curly braces are the nested objects. And I can say that like I get that all from the object, and I get that from my object. So in this case, from this one. And once you do that, so you just write down all the keys of the object that you're actually using. Then you can start using those keys as if it was a variable declaration. So it saves you from writing out all this whole dot notation. You can do something similar with arrays, but with an array, it's based on the index number. So here I have an array, and then I can destructure it. I can say let, and then between block brackets, all the indexes that I need, and then I can start using it. This makes sense for when I think this is probably mostly used for when you work with deeply nested objects that you retrieve from systems. Another new one is the for of loop. It's nice. In ECMAScript 5, when you were working with loops, you have the original for loop, and there's nothing wrong with the original for loop. You see that here, and I created the comment 1. I noticed myself, especially on a day that I wrote Java code and Python code and JavaScript code, and then at the end of the day when I write the JavaScript for loop, then I might mess up and do some quirky things. So the new way is much easier. You can use a for of loop. Another thing is like in JavaScript, ECMAScript 5, there's a for each loop. Is a bit simpler, I think, than the standard JavaScript loop. But a for each loop, you cannot break that one, and you cannot continue, and you cannot return. And then ECMAScript 5 also has a for in loop, but that makes more sense for when you want to loop through key values within an object. So that doesn't really make sense for an array. So the for of loop makes it a bit easier. So in this case, I have an array, and I can say for every index within the array, I do something. So there's no risk of creating endless loops or break loops, for example. Now, as a gotcha, I do want to tell you the ECMAScript for of loop is nice, but it actually performs a lot slower than the original JavaScript for loop. So if performance is a key thing for you, or when you create mobile applications, it's probably something that you need to think about. And even when you transpile it, and you use a transpiler like Babel, for example, it becomes even worse and becomes more slow. So if performance is a thing, you might want to stick with the old-fashioned ECMAScript 5 loop. Now there are also a bunch of new methods that you can start using. That is nice. For example, when you want to check for equality within JavaScript, so let's say I check if string 5 equals 5, then you use the double equal signs. This is stuff you probably all know. When you check against 5 string and you say double equal, then it says also true, because 2 equal signs only checks the value. And when you use 3 equal signs, it will check also the type. So 5 equals string 5, double equals is false. And when you use with 3 equals, or when you, the last example, when you say 5, triple equal 5, that's false. But the funny things here funny. I mean, something very strange is when you check if plus 0 double equals minus 0, that is true. And that's just, I think, a bit funny, because I would expect that that would be false. And even when you check it with a triple equal sign, it still tells it's true. Well, I would expect it would be false. And when I have 2 times a variable that is not a number, and I compare those to each other, it will tell me that, yeah, that's false. Well, I would say, like, well, 2 times not a number, still not a number, right? So that is a bit strange when you do these old-fashioned way of type checking or checking. And this is why object is, which is a new object, might be nice. It's a new method on the object prototype. So you can say object is, and then 5, 5, which is true. But if I do object is 5 string 5, yeah, then it's false, because that's not equal. And now you can see this example with the plus 0 and minus 0. And it will tell me, yeah, that's both is something else. And 2 times not a number, yeah, that's indeed true. So that could be good. There is a method called assign on the object prototype. That you probably want to do that if you want to create some concept like mix-ins. So like Senchai, we have our own mix-ins, but in JavaScript, if you want to create something similar like that, so in this case, I create a function called observable, and yeah, I do something in this function, and then later I create another object, or another object in this case, and then I can say, like, from the first object, I merge it with the other, so in this case with the object prototype, and in this example now, some object I can run .on custom event on, because I got that from the observable. Now there are a whole bunch of other methods that you can try to check out, like on object, but also on arrays, on numbers, and on math. There are all nice, cool stuff. I created some more GIST examples that you can play around with. So if you just then later tonight click on the links, then you can see that. Cool. Now then we have promises. And promises, that is for when you deal with asynchronous JavaScript code. So as you might know, when you execute JavaScript code, 2 pieces of code can never run the same time. It always goes from top to bottom. And it comes right after each other. That becomes difficult, or that becomes asynchronous when you do things like I make a call to a database, or I make a call to an external server, or I run a set timeout function. Something asynchronous is happening because the JavaScript code executes from top to bottom, and after it's done with executing, it will look into the event loop, see like, oh, what else? What other stuff that is asynchronous do I need to execute right now? And then it collects it from the event loop and start executing it. And the way how you would deal with that in ECMAScript 5, that would be with callbacks. And what you might know of callbacks, you put a callback in a callback in a callback. That works, but it can become like extremely difficult. So for this example, I created a Node.js example. In Node.js, I work a lot with calling data from a MongoDB database, for example. And in this example, I started with writing a callback function. So in this case, I call it var done. And I say, like, as soon as I'm done with collecting all the stuff from my database, then I render something on the screen. Well, in this case, I render it in my view, and I'm retrieving jobs. Or an error. And that means that I'm creating a getJobs function, and this function does something asynchronous. Well, it makes the call to my database. So you see, like, job.find jobs from a user. That's actually a Mongo database call. And then I execute it. There's nothing wrong with these pieces of code, and this is probably totally fine, but it becomes like totally difficult when you're think about it. In this case, I'm just retrieving jobs from a database. But what if I'm retrieving jobs from this database, and I retrieve addresses from that database, and I retrieve cars from another database, and they all need to be collected first before I render it on the screen. Those kind of examples, then when you work with callbacks, that becomes like extremely difficult, because then you're really like exhibit the example, like putting the callback in a callback in a callback, and then it's like, hopefully this will work. And this is where the ECMAScript 6 promises are very great for, because promises that helps you with more with the maintainability and readability of these asynchronous pieces of code. So if I would rewrite the same example with promises code in ECMAScript 6, I would probably think that I would think about it like as, how would I say it in normal English? Well, I want to retrieve jobs from a database, and then, after I retrieve it, I render it on the screen. Or else, if it doesn't come in or something went wrong here, then I'll throw an error. So I start writing that is all simple. And there's one thing that once I start writing this that I already know, and that is that get jobs in this case should return a promise. So that is what I can start coding next. I write the get jobs function, and this needs to return the promise, so new promise, that is what you see there. And the promise also needs to do something asynchronous. So typically in ECMAScript 6 code, when you say new promise, you pass in one argument, and that one argument is a function with a resolve and a reject. So I say like, oh, I do something asynchronous, so now I make the call to the database, I retrieve all the data. If it's okay, then I resolve the promise. So I say resolve jobs. But if there is an error, something went wrong, database is down, yeah, then I reject the promise. And as long as I return the promise, and it has you can fulfill or you can reject promises. So at that moment, this piece of code will work. And this makes much more sense. Plus, promises are chainable. So that means I could say get jobs, and then get cars, and then get addresses, and then render everything on the screen. So much better to read. Much better when you deal with callbacks. Well, we're getting close now. This is number 2. Classes. And just take some time to look at this picture, like, oh, I see what the problem is. You're not defining any classes. Well, Obama, classes in JavaScript or classes in ECMAScript 6, those are just syntactical sugar. There is no object-oriented system in ECMAScript 6. It are just functions, just like it is now. There are no classes. They don't exist. Actually, this picture would have been more funnier when, the day before yesterday, I think. But now at least we know that he should never really become a programmer. We don't know what his plans are for January. But so in ECMAScript 5, when you would define a class, you would a syntactical class. So if you want to do something that looks like a class, you would probably start with writing out a function. So in this case, a function called character, and assign some properties to the scope. And then I write a prototype. So I would say character.prototype.introduce, and I do something there. And then when I want to create an instance, so I can say like var Batman is new character, and then I pass something in that will be the name and the type and the universe in this case. And then I can call a method from this instance. So Batman.introduce. When I would rewrite this in ECMAScript 6 code, I can write the class syntax. So I can say class character, and then I can write a real constructor. I can pass in the name, the type, the universe. I don't need to end the constructor with a comma, just blocks of curly braces underneath each other. And then I directly start writing the method. So in this case, introduce, and I do something. Here you can also see if I would run a type of character, it indeed returns function, so not class. It is a function still. And now I can create an instance of it. So I say let Batman is new character. Batman is a superhero, DC, and Batman can introduce himself. With this class syntax, you can use it also in combination with getters and setters. So you would just write setters and getters in the class like this. You can even use inheritance with this syntax. So let's say that we have this character class. It's the same one, but now we can extend it. So I can say class is Wookiee, and a Wookiee extends from a character, and then I override the constructor. So in this case, all Wookiees have the type set to Wookiee, and the universe is Star Wars. And yeah, when Wookiees talk, they, Millennium Falcon. Yeah. So now I create a couple of instances of it. I can create a new Wookiee. I can introduce himself, and I can create. I can also create still a character. Now with these class syntaxes, you can also use static methods. So like statics within Sencham. So that means like if you want to call the method from the class prototype. So let's say I create a class called superhero, and it's quite similar like the character one. But in this case, I also add another method there, and I call the method static, and then get Marvel fact. So that means if I create an instance of superhero, so I would create var Spider-Man is new superhero, and I can run get name and from the Spider-Man, and it will set something. But I cannot run get Marvel fact from Spider-Man, because the Marvel fact only exists within the prototype, as you can see here. But if I say superhero.get Marvel fact, then it works. So that could be nice. So just keep in mind, like when you work with ECMAScript 6 classes, this is just syntactical sugar. These are functions under the hood, but it's definitely a nice way of writing out your code. Now the last feature that I like to point out is always goes hand in hand with classes, but those are the modules. That is also something that is new. You might have seen it maybe in Node.js already. Before ECMAScript 6, when you were sharing code, the scope was always global. So that could give you security or collision problems. And to solve this kind of scoping problem, there's now a possibility of loading modules or packages. Also, mind you, like JavaScript never really had a packages system, or no way of retrieving external scripts, basically. So that is what you can do now. There are some differences, though, because the module code that you collect automatically runs in strict mode, and you cannot opt out from that. You have to export it also, so that means, I can show you the example here. So let's say I create a module, and in this case I create a module leftPad function, because that's a function we developers all need, apparently, to create models from. So I export that to the on model. So I say model.export leftPad, and then my function that I created. And this is not a really important function, it just hustles the text. But now in my app code, so I save this as libs/leftpad.js, and in my app.js file or my index.js file, I can say I import from leftpad, or I import leftpad from this file. And you don't need to put the .js extension behind it, because it knows it's a JavaScript file. You could also say import everything from leftpad, and leftpad, it knows that it's leftpad because that is the variable that I exported here. So that can be nice to break up your code in smaller pieces. That is basically the answer for packages, but it fixes the global scope problem. But keep in mind that everything runs in strict mode, and you have to export it. There's much more ECMAScript 2015 stuff. Think about spread operators, maps, weak maps, set weak sets, generators. Now all this stuff, I created a blog post on my weblog that I create more code snippets from that you can play around with. Just had no time to write it all out and explain them all. But I just wanted to point out here that all these ECMAScript 6 features, again, is just for developer productivity. And since we are Sencha developers, we already do many things, or Sencha is a framework to help you as a developer for developer productivity. So there are lots of things that we already have an alternative for. And think about the tech templates, or the templates, the multi-lines. Yeah, that's in Sencha, that's X template. And object is, yeah, in Sencha we have ext object equals. Object assign, in Sencha we have ext.apply. Promises, Sencha already have promises support, is ext.promise. Supports and runs also across other browsers. Classes, Sencha has its own class system, ext.base. And yeah, models, yeah, Sencha has its own loader. So we already break stuff in smaller pieces of JavaScript code and load them. So there are many things that there's no really new reason for, but it's there. So what is the thing about ECMAScript and TypeScript? Because it's so hot right now, how will Sencha deal with this? Well, we have seen it already. Maybe you attended Dawn's presentation, or you probably have seen it in the keynote. Our goal here is, for now, for at this moment, that you can start writing ECMAScript code, and it goes hand in hand with the framework. So when you write ECMAScript 6 stuff, it will not break your current code base. And to do this, we have to create new tooling, or we have to make changes in our tooling, and that is what we did in Sencha CMD 6.5. So this is the newest CMD version. Will be out soon. If not, maybe it is already released today. Could be, but definitely this is the new CMD version. And Sencha Command or Sencha CMD is Java based. So this is not the stuff about the tooling that was introduced about NPM. That is for the next version. But for the version that is out today, that is Sencha CMD is Java-based, so it's CMD 6.5. And that will allow you to take your current XJS 6 code, XJS 5 code, maybe even XJS 4.2 code to write ECMAScript 6 in combination with that. But that means, like, for example, when you write code in a controller, or when you create your own custom functions in a model or a custom class. But it's not that way that you can write classes that extend from Sencha stuff. We will eventually support that, but in the next version. That is the stuff that Don was explaining earlier or yesterday. That you can create Sencha class, you can create ECMAScript 6 classes and extend from Sencha classes. But for that we need Babel, the MPN solution. For now we use Sencha CMD. Sencha CMD did make some changes under the hood. Before we used Rhino, and now we're making use of the Google Closure compiler. So that is the reason why we can transpile the code. Because we have to transpile the code because we still support Internet Explorer 8, 9, and 10, and 11. And that, yeah, so in those cases we used old ECMAScript 5 codes that the transpiler really created for us. And with that, I do want to tell you, just be careful about this, because what transpilers do is not always the best solution. It's not always best code. It's not the code that I would write. Well, it's not the code that I would write. Sometimes transpilers can do very weird stuff. Very funny things, like a for-off loop. It calls like many functions within each other. And that is why the performance suddenly becomes like, yeah, it's super slow. So for sometimes, I mean, you can think about it like, yeah, ECMAScript 6 is nice for readability, but yeah, there are some, I mean, the coin has a flip side. So to think about that. And also, always when you do write ECMAScript 6 code, take some time to take a look in your production build or in your test build. Just run Sencha app build testing, and take a look into the code and see what the transpiler wrote for you. Is that the code that you indeed expected? This is the stuff that I explained to you. So in the next version of EXT, we will introduce the new tooling that is based on NPM, and then you can extend from Sencha classes. So that allows us also, well, we have to make changes in the framework to inside of EXT base to support this. So yeah, I wrote down some resources online. You can take a look. I will make sure that this slide deck will be available later, and then you can get all the code examples and play around with it. I also wrote down some tutorials on my blog, but yeah, that's it. I think we have 5 more minutes, so if there are some questions, there is some time for that. Yeah, go ahead. Yeah, there is a way. I just don't know exactly how. I can, if we connect later, I can have a look for you, or we can ask Dawn, because I believe it's just a configuration in some file. Yeah. Any other questions? Oh, sorry, the question was, can I disable the transpiler? Yeah, and I believe there is a way, I just don't know. I just don't know if it's in app.json or if it's in one of the hidden files, but there's definitely a way, because Don did it for me a couple of days before. If there are no more questions, thank you.